Hey everyone, today we'll be learning about ionic bonds. So as you learned in a previous video, an ion is just an atom that either has gained an electron or lost an electron. So it's not neutral, it either has a positive charge or a negative charge. And I'll clarify that it doesn't mean it just lost or gained one. Atoms can lose or gain 2 or 3 electrons. So just to give you a pretty simple example, if we have lithium bonding with fluorine, when these two elements bond together, they form what's called an ionic bond. So lithium normally has 3 electrons, but it gives an electron to fluorine. So that's what this arrow is indicating. After lithium has given its electron to fluorine, that leaves lithium with 1 fewer electron than it had before, which gives it a positive 1 charge. So my lithium is positively charged. And then fluorine takes an electron. So after it takes lithium's electron, now fluorine has an extra electron, and electrons are negative, so fluorine has a -1 charge. So my fluorine is negative, my lithium is positive, and as you've probably learned in previous science classes, opposites attract. So the positive and the negative will attract to one another, and that's what forms an ionic bond. So in order to form an ionic bond, you need a positive ion and a negative ion. So on the periodic table, it's pretty easy to tell what charge an element is going to form. So the example that we used in the previous slide was lithium. So Li was right here, and lithium is in this +1 column. So that far left column will always form a +1 charge. And that is because everything in this column has 1 valence electron, and it can only give away 1 valence electron. So lithium, sodium, potassium always give away a valence electron, and when that happens, it takes a +1 charge. If you take elements like beryllium, magnesium, and calcium, this whole family, these elements will always form a +2 charge. So everything in this family has 2 valence electrons, and they're going to give those 2 valence electrons away, which is going to leave them with a +2 charge. So anytime these elements form an ionic bond, they'll have a +2 charge. We'll skip over the transition metals just for ease sake. None of the problems that you guys do will have to do with the transition metals. Since they have some kind of funky rules, we'll skip those and go ahead to the boron family. So boron, aluminum, and everything else in its family is going to form a +3 charge, again because they have 3 valence electrons, and they're going to get rid of those 3 and form a +3 ion. Everything in the carbon family is either going to form a +4 or a -4. So all of that means is it can give away 4 electrons or it can take. So just to give you an idea of why that is, every ionic bond is trying to get to an octet, which just means they're trying to get a total of 8 valence electrons. So going back to our last example, fluorine has 7 valence electrons, lithium has 1. So lithium gives its 1 to fluorine, and now this has 8. All right, and then once we get into the nitrogen family, everything in this family has 5 valence electrons. So in order for nitrogen to reach the octet, in order for it to get 8 valence electrons, it needs 3 more electrons. So it starts with 5, and it's going to take 3 more so that it can get to 8. And that's going to be true of everything else in its family as well. And then as we move towards the right with the oxygen family, everything here has 6 valence electrons, so they're going to take 2 in order to reach 8. The halogens have 7 valence electrons, so they're going to take 1 valence electron every time they bond with something. And when we're dealing with ionic bonding, the noble gas family kind of gets left alone. So the noble gases have 8 valence electrons, so they have no need to bond with anything. So we won't be concerned with them for this unit. So now when we're writing the formulas for anything that's going to bond together, we'll just take K and S, so potassium and sulfur. So if we want to figure out what the formula is going to be, we have to go back to our periodic table with the charges. So potassium is right here, a 1 charge, sulfur over here with the -2. So we have something with a -2 charge, bonding with something that has a +1 charge, and it's always going to be a positive and a negative coming together. And we have to figure out what my formula would be. So anytime we have these ionic bonds, we're always going to have a total net charge of 0. My K has a +1 and my S has a -2. In order for me to get to 0, I'm going to need 2 potassiums in order for that to work. So a little shortcut method when we're getting to the formula is we can take the 1 from potassium, crisscross it over to sulfur, take the 2 from sulfur, give it to potassium, and then as a formula that's going to give me K2S. The subscript here is telling me I have 2 potassiums and 1 sulfur. Just to give you a visual of what that would look like, so we have 2 potassiums, 1 sulfur. Each potassium has 1 valence electron, sulfur has 6, so sulfur wants to get to 8, so it's just going to take an electron from each potassium. So this potassium gives its electron here, this potassium gives its electron here. So sulfur has now taken 2 electrons, so it's going to be negatively charged, and my potassiums have each given 1, so they're going to become positively charged. So next example, we have calcium and fluorine. So we'll find calcium is in the +2 column, and then fluorine is over here in the -1 column. And that's really all the information we need to know in order to write the formula. So we know calcium is +2, fluorine is -1. So to get a formula from this, we just take the 2 from right here, give it to fluorine, the 1 from fluorine, give it to calcium, and then as a formula, Ca. And when there's a 1, we don't write the 1, we just ignore it, we assume it's there, and then F2, since F takes the 2 from calcium. And just conceptually, this just means you have 1 calcium and 2 fluorines in this bond. All right, so last example, we have magnesium over here in the +2 column and oxygen over here in the -2 column. This is where there's the rule gets just a little tricky, but we have a +2 and a -2. So when these two come together, 2 goes there. Instead of writing Mg2O2, the 2's just cancel out and you end up with MgO. Oxygen is looking to take 2 valence electrons. Magnesium is looking to give away 2 valence electrons, so you just need 1 of each. All right, so I hope that was helpful, and you guys can let me know if you have any questions, and I'll be happy to help you out.